We are so happy to see the interest for this event this year. It is wonderful to see you all here. This year, we are hosting Pioneering Computational Social Scientists. In this two-day event, there will be a total of 6 sessions, 5 seminars, and 1 workshop. For digital credentials and GE 250-51 points, an attendance link will be sent through the chat in mid-sessions. So before we begin, there will be a short poll about the expectations for the event. We will also send another poll at the end of the event. So it should come right now. Okay, I'm seeing the answers. That's good. Okay, let me also start the recording. All right. Erdem Hocam, welcome. Thank you for accepting our invitation. It is a great pleasure to host you here for the opening session of this event.
Thank you very much. Thank you very much.
Erdem Yörük is an associate professor at Koç University in the Department of Sociology. His research areas include social welfare, social movements, political psychology, and he's also working on a very interesting project called the Emerging Welfare Markets. So without taking further time, Hocam, I would like to give the stage to you. Thank you again for accepting our invitation.
Thank you very much, and thanks for inviting me. I'm really excited. So my name is Erdem Yörük. So I am a sociologist. I teach sociology at Koç University, and I also serve as the director of a new research center on computational social sciences at Koç University. So this center has been very recently established, and I really would like you to follow and to join the events and activities of our new center. And we really hope that this will, the center itself will facilitate CSS research and teaching in Turkey. And I'm very much excited to see so many people here in this event, and that's really exciting. I have learned a lot from this many people. So this shows us that we have started to do something important. So today I will talk around half an hour, and so I will talk about the use of the concept of computational social science in general, why we are doing this in these days, in this time of history. And then I will start talking about my own project, which uses CSS methods to understand a sociological phenomenon. So we have 2 years ago, we have started a new computational social science master's program at Koç University, and I will be really happy if you also consider applying to our program. We are waiting for you. But in our classes, so we tell the story. So why now? So why are we doing this CSS methods so much? So there are a couple of factors. First of all, there is this big rise in the amount of digital traces, so digitalization of life, and existing forms of society has been digitalized, and we have seen like entirely new forms of social phenomenon in the digital form. Therefore, so the amount of digital trace data has been exponentially increasing in the recent years. So this is something new. This is one factor. And the second one is that there have been quite important mathematical innovations that facilitated the capacity of social scientists to use computational methods. And there have been some tricky issues in AI, the mathematics of AI, and this has been resolved. And the third thing is the increasing capacity of the computing power. And this is also a funny story. The GPUs has been quite important, and the GPUs, the expansion of GPUs is very much related to the rise of video games. And the commercialization and expansion of GPUs has been a critical factor in the expansion of AI everywhere, and also in social sciences. So interesting thing is that AI and like machine learning and deep learning, so they have not been invented recently. I studied electrical engineering at Boğaziçi University, and in 2001, I remember there was a course on artificial neural networks, and the theory and as a course, I mean, the theory and applications of AI methods and deep learning methods, artificial neural networks is basically called deep learning, but they were not put in use because of the challenges that I just described: the rise of GPUs, the rise of digital traces, and some innovations in math enabled this use of such AI methods in such huge extent. And we are now enjoying it. So we are now able to answer all sociological questions with new digital trace data. And also we are able to now ask like quite new questions with that are enabled by digital data and AI. Having said that, so let me talk about a problem, a sociological problem, and how we use CSS methods to resolve this problem. This is an ERC project, like European Research Council has funded us to make a groundbreaking research and innovation and something new. And the main output, the main dependent variable that we are trying to understand and explain is the social welfare state. And so, as you may also observe, social assistance programs all around the world, not only in Turkey, have exponentially increased in the last 2 decades. And the question is why? And if the question is, I'm not going much into the details of this social policy literature, but if this if this new phenomena indicates a new welfare state family, a global family. And the second question is, which is not for some reason seen here. The second question is, what is the cause of this welfare state expansion? And I argued that the main independent variable, the key parameter, is social movements, because governments are using social assistance programs to demobilize, to pacify, to contain poor people's movements, and they are delivering social assistance to contain, to buy off poor people. And therefore, if you want to understand the expansion or distribution of social assistance programs, you need to understand what happens to protest movements and social movements in general. Okay, this is the main argument. But we didn't have data on protest movements, and therefore we had to create such a data. when we talk about social movements, this includes strikes, street demonstrations, group clashes, all sorts of contentious politics or social movements. But usually we only have data on strikes because they are recorded officially. But other forms of protest data are not available to researchers. And sociologists and social movement scholars have long tried to create their own data on social movements, and newspaper archives have been the most important source because newspapers are reporting about social movements, and these are excellent archives about social movements, but you have to extract this information. And therefore, since the 1930s, many sociologists collected data from news archives in a manual way. I mean, even I did myself in my PhD dissertation, which I defended in 2012. I created a protest event data set manually. I sit down and at Boğaziçi University Library, and this microfilm machines, maybe you remember from movies. Then so I look at every single news articles that were published, and Cumhuriyet daily articles published between 1970 and 2010, and I was almost dying. Okay? So this was a horrible experience. So I said no one should do this again. And then after I defended my dissertation, I started to work at Koç University, and then I applied to a European Commission grant. With this grant, I started to compare Turkey and Brazil, and this was the first moment I started to analyze automated methods of protest event data collection. And then I have seen that there were already some projects in automated protest event creation, and these automated methods are fast, they are replicable, they are sizable, but the quality of existing data sets were low for some reasons that I will talk about. Then in 2016, I was awarded this ERC grant. This time it was a big grant, like 1.5 million euros were awarded. So we had the opportunity and time, 5 years, to try different things, experimental things. And then I built a huge team of computational social scientists, computer engineers, and we have all become computational social scientists en route. And so the interdisciplinary nature of such projects are really exciting. So computer scientists learned a lot social imagination, and sociologists have learned a lot of like Python and data collection, etc. So it's a really, really good exchange. And what we are doing, so we have created a set of tools to automatically extract protest event information from 6 different countries: China, India, South Africa, like Brazil, Argentina, etc. In 3 different languages: Spanish, Portuguese, and English. And then Turkey was already coded in manually, and we are, as you can imagine, we did use natural language processing and deep learning methods. And first of all, we do data collection. So our raw data source is online news archives in local languages in these countries. For example, we start with India, and we were lucky because the best newspapers in India are published in English, and they are really, really high quality newspapers. And we download the entire archive of such like 3 different newspapers in India, which means around 12 million articles. And then we do a classification task to understand which one of these 12 million articles contain protest information. Okay, so this is a machine learning model, and that supervised machine learning, and that's why we needed annotations, annotated news articles. Then we built 2 annotation teams at Koç University and at the University of Sao Paulo, and they were our Brazilian colleagues annotated Spanish and Portuguese news sources, news articles, and our team at Koç University did English annotation. And then we randomly choose 10,000 news articles out of these 12 million articles, and from India, and then our annotators labeled those articles that were about protest events, and around 800 of them were about protests. And this, and in protest event collection, the data is quite unbalanced, and around 5 to 8%, usually 5 to 8% of protests about articles, news articles, are about social movements as we define them. Then with these annotations, so you have to understand the learning curve, and you have to continue annotations until you have enough number of positive cases to be able to feed your machine learning model. And then until you have a really high performance to identify protest events, and you measure this performance in terms of F1 scores. And then so we did a really, really good job. So I mean, we have a high really good performance, over 90%, so we can identify protest news, protest events in English, and then Spanish and Portuguese language. Then we continue to detailed information extraction, which means then our annotators continue to identify detailed information in the protest-related documents. First thing, but where is my anyway, the first thing is to identify which sentence in the news article is about the protest, and then in that sentence or sentences, then you they tagged, annotated, or labeled the participant of the protest, organizer of the protest, the location of the protest, the demands of the protest, etc. Detailed protest informations, characteristics are labeled by our annotators. And in total, from India, this was over 800 documents, 800 news articles. All positive ones were annotated in detail. Then, so each article is annotated by 2 annotators. So this is called double annotation, which ensure the quality of your gold standard corpus, your training material for supervised machine learning. And So you have to ensure that there is a really high inter-annotator agreement. This is the most critical thing in supervised machine learning. If you are creating your own data, if you are not using like some digital traces, but if you are creating your own training data, you have to ensure that your training data is of high quality, because AI is a poor child, so he is learning whatever you are teaching to him. So if you are teaching the AI something ambiguous or something wrong, then it will imitate this fake information, and it will identify wrong characteristics. Therefore, each time, and so each document is annotated by 2 people, and then we calculate inter-annotator agreements, and then we have our annotation supervisor is an experienced social scientist, does the adjudication of annotations, that which means if there is a conflict between 2 annotators, if one is saying that this is protest and the other one is saying this is not protest, and then this conflict has to be resolved, and the supervisor goes over all conflicting cases and then corrects as an experienced third eye, corrects the data. Then in the end, so this took us around 2 years and hundreds of thousands of euros. So we created a huge gold standard corpus in protest event, automated protest event collection in 3 different languages in different countries. I mean, even if we had failed in our AI mesh tools, this gold standard corpus itself was a really good contribution to CSS and computer sciences. Yeah, because this annotated labeled data is really extremely valuable. So our corpus, as I said, it's a gold standard corpus, meaning double annotated and corrected. And we choose the documents to be annotated as a random sample. What does that mean? So in all other automated protest event collection like projects, so you and all of them are using supervised machine learning, you have to annotate and label some data, right? And we know that protest data is an unbalanced data, like around 5 to 8% of the articles are about protest. Therefore, if you choose as I said, we randomly choose 12,000 articles out of an entire data set of 12 million articles in the archive, right? And then out of this, around 800 of them were about protests. So this wasn't unbalanced data, and we needed around 800 to 1,000 documents to have an efficient AI tool. Therefore, in order to attain this 800 numbers, you have to increase the total number of annotations extremely. So in the end, we had to annotate 10,000 articles. And this is a really costly thing. And since we had the budget, we were able to do that. But usually what do people do? They use some keyword search, and they use keyword filtering. Like the people create a long list of keywords that are about protests, like march, demonstration, strike, etc., etc. Then they look for these keywords and they search for these keywords, and the returning articles, the corpus of articles are then annotated. In this sense, you can reduce the number of needed annotations because like maybe at 2,000 or 3,000 annotations would be enough. But what is the cost of this thing? You can never be sure that the keywords are exhaustive and they are representing the social assistance domain in a country. And if you are working on a single country, this is still not too bad. But if you are doing comparative analysis, then your keyword sets are impossible to identify all protests in all countries. Okay, therefore, doing random sampling is the only way to like obtain generalizability. If you want to have generalizable, like generalizable over time and generalizable across countries, you need to do random sampling. A protest form that exists now will cease to exist in the future, or you can have new protest forms over time. People do something quite new out of sudden. And then if you use keyword filtering, then you would not be able to identify them. Then, so as tools, so we used BERT. So we were lucky because after we started the project, those kind of pre-trained models were available, and then they incredibly increased our performance. So reliability and validity. So I talk about this generalizability issue. So I talk about this task from documents. Then we identified protests, and then we identified event sentence. Then we identify all other protest information. Yeah, so this is our data set, Glocon. So this we are finalizing our website, but in a week or so we will release our data set. But you can already go and check. It is hosted at Glocon at glocon.ku.edu.tr something. So if I can maybe do can show you the outcome here. Let me share my desktop. Yeah, this is our dashboard. My internet connection is not really good, so I hope. So let's choose India, for example. And then, so this is like sahibinden.com. Okay, so you choose not a 2-bedroom, but you choose, for example, a demonstration, and then it doesn't take much time, but I'm connected with my cell phone. Like, let's choose student movements, and then you can like student demonstrations organized by a political party, and then you can, for example, color it by urban or rural, okay? Or you deselect the organizer, and then you then color it by the type of organization. Okay. So therefore, our data set, the output data set, the protest data set in many countries, they are available online if you are interested in social movements research. Or our annotations they are also available. If you want to do some automated event collection, protest event collection, etc., so please contact us, because we will be happy to share our very good gold standard corpus annotated material with you. And so let me go back to my presentation. Yeah, I talk about them already. Annotations. Yeah, ethical aspects. So what the data that we created is really interesting, but it can be really harmful for social movements, because so governments or security organizations can use this data to predict future protests. There is a lot of literature and research on protest forecasting. And also they can identify in like communities and groups and localities like hotspots, protest hotspots, and they can implement some counterinsurgency measures, etc., etc. So therefore, so we are trying to do our best to protect those movements, and therefore in our data we have created our own data sharing policy and protocol. We are accepting applications for data sharing, and we ask applicants to tell us if and how their study will be beneficial for social movements, or at least not harming social movements. If this project that is requesting the data is or has been supported by a security organization. This is important because almost 90% of all automated protest or conflict event projects are funded by IARPA and DARPA. So these are institutions of Pentagon. Okay, so this is a really dirty field of research. Therefore, we had to be really, really careful about the outcomes of our many years of work, actually. Yeah, I think that's all. So we have 5 to 10 minutes left, and we can maybe continue with your questions.
Thank you, Hocam, for the presentation. It is very interesting to hear about the huge data set that you have been working on. So I have some questions as well, but I think Emir has a question, so you can just go on, Emir, if you have. Anyways, for the time, I can just go on. So, Hocam, I was wondering, how are you, or are you measuring the size of the protests? For example, an event might have a huge influence on the news, but in reality, it is not that much of a protest. So how are you handling the size of it?
Yeah, this is an excellent question, and we have thought about it and work on it a lot. So this is called the deduplication problem. So how do you measure the importance of an event? Because if you collect you can use the size of participants, or you can measure the size of the violence, or you can measure the number of casualties. or you can do many things, but still it is, because in many times you are comparing apples with oranges, because, for example, 9/11, so this is an extremely important historical event, but participants were 2 people. I mean, so, and in an event is only a single event. And if you, for example, there can be a single strike here in Dudullu, and if you just compare the number of participants and the event number, so the Dudullu strike will be more important. Therefore, our solution to this problem is to collect news information about protests as many times as they are reported in the newspaper. For example, an important event is mentioned in a newspaper in several times. And therefore, we are here measuring the importance of events through the lenses of newspapers. We are relying on newspapers, and we are assuming that if an event is important, then it is reported by the newspaper more than an unimportant event. Therefore, but still, there is this problem of deduplication, because a researcher can be also interested in the absolute number of events, like single, like 9/11 is a single event, or etc. But this is a challenging task, because there are like 500 times 9/11 is reported. So then you have to identify or like collide back all repeating representations into that single event. And we are working on that. It's a really challenging task, but at the moment, so we are releasing the unduplicated data, which also indicates the importance of the event, actually.
Thank you, Hocam. So any questions from the audience? You can just raise your hands or type it in the chat.
Merve.
Yes, Mary, please.
Erdem Hocam, thank you for this very insightful presentation, and also for your data set. I think we are going to use this a lot, especially in political science and sociology. And my question is, why did you choose these countries at the beginning? And have you find any generalizable trend regarding the social movements?
Okay, so I have chosen these countries because I have shown that these countries in question, they form a separate and new type of welfare state. So they are different countries, geographically, historically, politically, culturally, etc. But they are converging. They have converged into a single welfare state family. Therefore, this is a perfect most different systems design. So they are diverging in all important parameters, but in terms of the output variable, they are similar. Then if I can find a single independent variable, which is also similar across the cases, then I will be able to show a causal relationship between this independent variable and dependent variable. So all of these countries are quite different in many ways. They are also similar in the composition and trajectory of social movements. And then this convergence or similarity in social movements was responsible for the convergence and similarity of social welfare programs. And what did we see in like similar in terms of these countries in social movements? The center of social movements in these countries have shifted from formal working classes into informal working classes and rural populations. So this was a pattern, and this was actually explaining my original question of why social assistance programs are expanding so rapidly, because social assistance programs were really efficient in demobilizing and containing the newly insurgent informal populations. I don't know if this was helpful.
Yes, hocam, thank you so much.
Burak, I think you have a question as well.
Yes, thank you. Hocam, thank you for the presentation. I'm very interested in machine learning in social sciences, and I'd like to ask how your coding is differentiating between the opposition media and state-led media. I mean, state-led media would underestimate the numbers and attending groups, while the opposition media would overestimate the numbers and the groups. So how the machine learning would collect data about this and differentiate between these two types of data?
Yeah, this is also an excellent question. So this is called the source selection bias problem. And this is a real problem. I mean, editorial choices of news sources, reliability of news sources. Some of them are just lying, or some of them are just censoring. For example, in China, it's really difficult to find protest events because, I mean, news papers published in mainland China, etc. But this is, I mean, this is one of the key reasons why we choose automated methods, because manual coding, in manual coding, you, with your limited capacity, you can only study one news sources if you are doing a long-term analysis, and you have to continue and try to survive with the existing biases of this single source. But in automated methods, we can choose as many sources as we want, from right wing to left wing, from the opposition, from the government. And then our assumption is that in the long run, and if you cover like a diverse set of news papers, then their biases would eliminate or cancel them each out, cancel each other, cancel out each other. Therefore, so you are not overcoming this problem, but you are just trying to minimizing it. So minimizing this ideological choices and biases. And importantly, somehow, some news, I mean, government, like pro-government newspapers, they may be reporting more about protests, but their language would be different. I mean, then opposition can call some protesters as activists, but the pro-government would call them terrorists. So these are also issues, but the number and the frequency of reporting, usually opposition newspapers, obviously, they are reporting more. But in short, the answer is to cover as many news sources as possible.
Thank you.
Welcome.
There is also a question in the chat by Efe Gülkan. I am reading it right now. How can you eliminate the reliability of sources in automated data extraction?
I think this was a similar question, right?
Yeah.
If you refer to the same, like source selection bias, I think I tried to answer this. Okay, good.
So any questions? If there are no more questions, we will be ending this session.
Let me do some announcements.
Of course, hocam.
So I don't know if you are familiar. So this is another EU project that I am coordinating. It's called Social Comquant project. So this is hosted at Koç University, and the objective of this project is to develop teaching and research infrastructure in computational social sciences and to help people interested in computational social sciences. And this is the last year of our project, and we are organizing workshops, like the summer schools, and we have an exchange program, and so we will like release our online CSS tutorials and materials, and therefore I would recommend you follow this website and our social media accounts, and our new center for computational social sciences at Koç was established as an outcome of this project, and so we will be releasing our new website for the center as well, and it's really good that all other really great scholars that listen to, they are also really nice people in terms of like personality, and we are good friends, and so we are working together, and like for example, Akın Hoca has been organizing this summer institute in computational social sciences for a long time, and he has invited many of us to co-organize this event in the future, and so this will hopefully create a synergy. This year we will have the Social Comquant third summer school in Italy, and so we will provide we will cover the cost of transportation and accommodation to Italy, and also we will organize a series of 10 more workshops this year. So you are interested in CSS, and there are growing resources in CSS as really good timing for you, and please contact us, and if you have any questions, and I hope that you will consider applying to our master's program this year or in the future, and I wish you a really good today event. Thank you very much.
Thank you, hocam.